space radiation could be a major concern for astronauts traveling by plane from what scientists thought, at least in the near future, a new study suggests. The radiation dose rates of the measurements obtained in the last 4 years exceeded the trends of the previous solar cycles by at least 30%, which shows that the radiation environment is much more intense. These particulate radiation conditions present important environmental factors for space travel and space weather, and must be carefully studied and taken into account in the planning and design of future missions to the Moon, Mars, asteroids and beyond. Schwadron and his colleagues studied the observations made by NASA's Lunar Reconnaissance Orbiter (LRO), which has been circulating around the Moon since 2009. Specifically, they analyzed the dose rates of galactic cosmic rays measured over the past 4 years by the telescope of cosmic rays of LRO for the effects of crater radiation. GCR galactic cosmic rays are super-energetic particles, mostly protons and atomic nuclei, which have been accelerated at tremendous speeds by distant and dramatic events, such as supernova explosions. GCRs can damage the electronics of spacecraft and, in large enough doses, can cause radiation sickness in astronauts or long-term problems such as cancer. We now know that the deep space radiation environment we could send human crews to at this point is quite different compared to previous missions manned to the Moon, Schwadron said, referring to NASA's Apollo missions, which landed 6 crews on the lunar surface between July 1969 and December 1972. The increase in GCR levels is related to a prolonged stretch of low solar activity, which decreases and flows in a cycle of 11 years. During the active phases, the magnetic field of the Sun is spread throughout the solar system more extensively by the flow of charged particles known as the solar wind, and diverts more incoming GCRs.